similar to the coplanar forces. So this is on 3D. Yeah, so we're going to look at three-dimensional of the force vector. It's similar to coplanar, but it's just that now it is in 3 dimension. Yeah, so first thing you need to do is, of course, all the time you have to draw the free body diagram, and then you apply the 3 scalar equations. So this is what you're going to be achieving at the end of this chapter. So application is almost everywhere, yeah, because everything around you is actually 3-dimensional, most of it. So please anticipate this question in your final exam as well. Yeah, it will be a very applied question. So if you see, this is the actual drawing. So how do you assemble it? You just need to draw a ring there, and then weight and 3 weights. But this, of course, in 3-dimensional. Now look at this. This is a shear leg rig, derrick. So we have 200 kilograms of fish down here. And then we have got the legs here, and then the cable. Yeah, so I'm going to guide you. So just pay attention. Yeah, so remember, when it's in equilibrium, once again the summation of forces in all the axes will be 0. Fx 0, Fy 0, Fz 0. Okay, so if you have for F3, you break it up into ijk. You have F1, you have to ijk, and you have F2, you break it up into ijk. So this will be an example. Now once again, I'm skipping the example in the lecture note because it's rather simple. So I will move on to the textbook itself. Yeah, the example in textbook, because it's a bit more complicated. Yeah, a bit more challenging than the what you call the lecture notes. So you can actually do it yourself. Yeah, the one that's in the PowerPoint, the example is the PowerPoint. It's very straightforward. You can just do it by yourself. I'm looking at example 3.5 from your textbook. So let's look at this challenging question. A 400 kilonewton load is suspended on the hook. So we have 450 suspended on the hook. If the load is supported by 2 cables, you have 2 cables and a spring. The stiffness of the spring is 8. Yeah, so you know F equals to Kx. Okay, keep that in your mind. And then the cable stretch, determine the forces in the cable and stretch of the spring for the equilibrium. Cable AD lies on the XY plane. You look at that. This AD is actually between X and Y. So it's a you just have IJ. Yeah, you only have IJ for AD. You do not have the K because it's a single plane. And cable AC is between X and Z. What does it mean? You only have I and K, value of I and K. So you have to take note of that. Otherwise, you'll be like figuring out how to find the missing vectors. Okay, now let's do one by one. Okay, we're going to break it up into one by one. Yeah, so we have the first thing. We look at axis by axis, so it's easier for us to see. Okay, now let's look at axis X. Anywhere that's in X. So we have FD. So this side will be cos. So the opposite will be sine. So FD sine 30 in the positive direction. FB got nothing to do with x-axis, and then we have 450 nothing to do with the x-axis, and then we have this flat one 4 over 5 FC, 4 over 5 FC, and it is pointing this side, so that's why it is negative. Okay, so we have done with that. Next, move on to the y-axis. So in y-axis, what do we have? Okay, let's look at y-axis. So y-axis, we have FB, which is in the positive direction. Okay, that's done there. And we have this got nothing to do with y-axis, and this one is in between x and z, so this also got nothing to do with y-axis. Or this one, yes, it affects. So FD cos 30, close the armpit, so we have FD cos 30, and it is in negative direction because it's pointing the other opposite direction. So that's what it is. Yeah, so we have solved for x and y. Now we're going to go to z. So we have 450 pointing downward, negative. This got nothing to do with the z. This got nothing to do with the z because it's between x and y. Yeah, and this one. Okay, so we make it vertical, 3 over 5 FC. Yeah, so we have 3 equations, 1, 2, 3. If you solve this 3 simultaneously, you get the answer for FC, FD and FB. I'm not showing the simultaneous calculation here because that's very mathematical, yeah. So once you have your FB, okay, referring back to the question, we always have to refer back to the question, whether are we answering the question. They have actually asked you determine the forces that we've done, and stretch of the, they want to know the stretch of the spring. Okay, so where's the spring? The spring is at FB, isn't it? Yeah, the spring is FB. So FB. So FB 1.04, okay, equivalent to K. K value was 8 just now. SAB. So SAB is 0.130. Yeah. So with that, I've actually completed chapter 3. Please do and solve the questions that is assigned to you and upload it on eLearn. Yeah. Please follow the deadlines. I will see you in chapter 4. Thank you.